Good evening. Welcome to the week 6 doubt clearing session of fundamentals of additive manufacturing. I hope I am audible.
That's fine.
Yeah. This week, the sheet lamination process, another state-of-the-art classification of additive manufacturing, was studied. So we are going to start with the lecture notes of sheet lamination process. Then we will move on to the previous year questions solved, and I have some extra simple questions in Mentimeter that we will try to solve. So let's start the presentation. So as I said, mainly sheet lamination process was discussed. So under the state of the art, the huge umbrella of sheet lamination process, there are different processes which are coming under this state of the art. So one process is, for example, laminated object manufacturing. Just as have seen in the last liquid AM process, in sheet lamination also, if I classify further the sheet lamination process into various kinds, then these will be the subcategory based on which I will be subdividing the process. So first is, what are the material being used? What are the approaches to join the material? What will be the cutting method? So sheet lamination is a type of additive manufacturing which also include a cutting process inside it. So it becomes which make it like a hybrid manufacturing process where subtractive and additive both are taking place at the same time. In other AM processes, we have seen that we just deposit the material. The material comes from a nozzle, or the material is spread, or we have put the material and the energy source is coming by somehow. We are depositing the material, but we are not cutting anything. We are not, there is no cutting operation taking place. Cutting operation comes in the subtractive manufacturing part. But here in sheet lamination, both takes place at the same time. So that's why cutting method is also one option for the category. Then bonding method, like how the material is getting bonded to each other, like how the layers are getting bonded to each other. Then joining region, whether we are joining the entire region or selective. This point is also very different from other aim processes. So just note down that this cutting method and joining region, these are the two new things we have introduced in this sheet lamination process. In any other AM process, we do not join or we do not fuse the other part than the selective area. If you talk about liquid AM, if you talk about metal AM, if you talk about fused deposition modeling, or any metal jetting, binder jetting, we just are concerned about the region where we want to print, where the part is placed. Like we join the selective portion of the whole will plate. But in few processes under sheet lamination, we join the whole region. After the process, we delete or we remove the excess part around the actual part. So in the material, we have options like paper, plastic, ceramic, metal. So these are the only materials that we can join. However, I would like to mention that paper is the most common thing people use for sheet lamination. Metal is also been used, that comes under a different, very different process under sheet lamination. Plastic and ceramics are very rare. You can see three lines are going from paper, but only one lines are going from each three of this rest of the material. Approach process, it can be bond then form or form then bond. Now, what does it mean? Bond means how these two or three layers Like this consecutive two layers are getting joined. That is bond. And form means, as I
Cutting.
said, there is a cutting operation. Sorry.
Yeah, foam means
As I
cutting.
Yeah, so form means cutting. So how the cutting is taking place, whether cutting is first, then joining, or joining is first, then cut. Now for cutting, we have options like laser, knife, milling, or water jet. And then bonding method, in bonding method, it can be adhesion, it can be sintering, diffusion, spot welding, or soldering. Joining region, we can join inter-region or selective region. So now let's see the different classification. So first, I would like to discuss about the main process physics of sheet lamination. So what happens? There will be a sheet of paper, for example. This is my bed, and onto which the sheet of paper is coming one by one. And these sheet of papers are not separated from each other. There is a big sheet which is mounted in a roller. And from the roller, for example, there is a roller where the sheets are wrapped around. And from the roller, these sheets are coming and placed over the bill plate. And over the bill plate, there is a knife. For example, the knife is cutting the paper in the constructive way, like where you want to make the part. Then the excess paper will go to the beam, and that remaining portion will be here, which we have cut using the knife. Now another roller will come and it will roll over the paper sheet, and it will press and give some heat to the sheets so that the two adjacent two sheets, one or two layers, can be joined together. This is the process, overall process of sheet lamination. So that is what discussed. So here, form and then bomb means first the knife is cutting the part in the selected region, and then the pressing, roller, or joining like welding, or the operations are taking place by which you are joining the two sheets. In other way, the bond and then form are different process where you have joined two sheets already together, and after that you are cutting the rest of the portion where you do not want to print the part. So that is the bond and then form, and first one is the form and then bond. So the first process we are going to discuss is cubic technologies LOM. LOM is laminated object manufacturing. So cubic technologies loam uses paper as a material, then bond and then form, like it will first fuse and then it will cut. They are using laser for cutting, and the bonding method is adhesion. So that means the papers will be adhered to each other by some means of glue or pressure, and the entire region is joined. And then from the entire region, after the process is done, the extra part, the whole extra part will be cut from the entire bunch of paper. So CAD file preparation and everything is done. So this is one thing. The object is positioned and oriented in a desired place, which is true for all the cases. But here we purposefully place the object in 10-15 degree tilted with the horizontal. So if your part is looking like this, we do not print it like this. We print it like tilted in some angle. like this. Why is it so? So if you see the process of cubic technology's loam, then how does it take place is, first, if you see this picture, this is the roller that I was talking about. This roller is coming, is placed over the build plate, and the extra part will be collected here. So when it is placed, for example, this is the first layer. So it is placed. Then this laser comes. This laser does this line cutting over the build plate where you do not want to print the part. For example, if this is the pink region circular, this you want to print, and this is the region where you want to print, then first I will cut this, that this is my whole region where I want to print. Then this is the outer boundary of my geometry. So basically the laser will move on the outer boundary of the geometry, not inside the geometry. This is very different from other processes. In other processes, the laser is used to join the material. So the laser will be scanning the inside portion of the part, but here the laser is not used to join the material. Here the laser is used to cut the material. So that's why it will scan the outer boundary of the part, not anything inside the part. So as it is hollow from inside, so inner boundary will also be scanned, and then it is making some lines like this. That means it is cutting, but the cut portion is not going anywhere. It stays over there, but it's cut. This portion is cut. So now when the sheet goes on and the next layer comes, you can see this portion is cut, the outer thing. This is hollow now. Okay, this was the first layer. Now this is the second layer. This was the first layer. This is how when the part is made, you can see the whole cube is getting made, whereas my part is just this pink portion which is inside. So when everything is done, we take a knife, and how the bonding is taking place, it's the laminating roller. So roller will move onto the part with some pressure and some heat. The heat can be there, can be removed also, but pressure will be there. Out of the pressure, the bonding will take place between the papers, and people can use some means of glue as well. So the roller can have some glue as well, which it will also spread over the paper so that the next paper can be glued together. So that is the bonding mechanism, which is pretty easy, pretty simple. But the forming mechanism is little bit difficult. Now what will happen? Now the laser has scanned, if you can see this blue lines, this square blue lines. This is how the laser was scanned. The laser has scanned the whole area like this, the squares. So when all the things are done, it's like this operation. There will be a shovel, or there will be a spatula or flattened spatula, something like that you have to take. And then you have to just remove the portion that was laser scanned. It's called a decubic, because you can just imagine there are small cubes which got generated because of the laser cutting operation, and now you want to remove the cubes. So this is how one by one you can remove the cube, and ultimately you can get the part. So this is the overall cubic technologies LOM. Advantages are only boundaries to be addressed, not their interiors. Therefore, fast process, since speed is proportional to the surface area of the object, not its volume. So here the only problem is in do you want to say anything?
Yeah, actually, he
Yeah.
told that um, the plane of the paper should be made inclined during
Yeah. Yeah. Yeah.
laming.
Yeah. So if you see this part, if I make it 90 degree, then there will be a lot of if you see this part, what we have, I have seen. So
There, I did not
this part,
understand.
if you place it 90°, there will be a lot of surfaces which are perpendicularly there during the cutting operation. Like the cubes will be there, lot of cubes will be there. If you do it in inclined way, then you can minimize some cubes which are directly connected to the part. Because when we are decubing the cubes, the support structures, you can say, you can hamper the part, the portion, the surfaces where these cubes are directly connected. After removal, there can be some dents, there can be some roughness, there can be uh, some distortion in the geometry. So just to avoid that, we put it in an inclined way so that we can avoid some 90° connections with the surface of the part, with the supports.
That means the plane of paper is not exactly horizontal.
Yeah. No. The paper is spread horizontally, but the part you are making now, you have placed the part in the STL in your software. There you have put it in an inclined way. So the part
Okay,
is getting made in an inclined way.
that is in pre-processing
But
stage. Huh?
yeah.
In the
But
slicing itself,
in the
in the
slicing
slicing,
itself, you have make it inclined.
okay, in the slicing stage, that is in pre-processing, not during
Yeah.
building.
So
So,
the whatever way you are slicing your part, the same way it will be getting generated, or it will be getting printed. So the printing will be like the ultimate part is inclined, not straight. But the paper is coming horizontal only, 0° with the
no,
horizontal build plate.
this step we should uh,
You should do in the pre-processing.
yeah, we should do in pre-process stage.
Yeah. It's like how you are orienting the part.
Yeah, means the face of the uh, part is not perpendicular to the.
Yeah.
It
Yes.
is not perpendicular to the vertical.
Yeah. So
Okay.
this is the thing. Now, after decubing, your part is ready to use. So advantages are, as you are not concerned about the inside of the part, so you're not touching anywhere inside the part. It's getting generated automatically. So that's why it's less in time. Because in other processes, you are scanning the inside of the part, or you are curing the inside of the part in case of resin wala aim processes. But here you are not touching anything inside the part. You are just scanning with the laser outside the part where it is going to remove. It is going to be removed. So that's why time taking is less during printing, but decubing operation is lengthy. It takes several hours. That is also kind of a disadvantage. The environment doesn't affect anything on the process. So you do not have to you do not have to build a chamber with an argon gas or nitrogen gas, which again saves your money. However, exhaust is required because you are cutting the paper or the wood or something with a laser. Because of the cutting, there will be smoke, fume. So the fume needs to be taken away from the chamber. Otherwise, the exhaust will be not good and it will be not good for the operator. Also, it employs CO2 laser, which is cheaper. CO2 laser is used for cutting operation. You do not have to go for any hi-fi diode laser or fiber laser, which is very costly. So CO2 laser can do the work. If you are using paper as a material, obviously paper will be cheaper than any other raw material which is used in any other aim process. And lastly, if you are really using paper or wood, then you are going to use it for prototyping or you are going to use it as a mold for the castle. So the
This is
mold will
pattern.
be pattern. Sorry, yeah, the
Not
pattern. So the pattern will be used to make the mold. So the pattern, if you can make it using sheet lamination process, then it will be very, very cheap. But at the same time, as you are using laser to cut the sheet, you can have some small features also inside the part, which you can later on use to make your mold. So that these are the advantages. And it needs very less amount of or less number of tools. So that is also a good thing. Decubing is the main disadvantages. Fixed layer thickness is one problem. Here, it's not like that you can play with the laser process parameter and increase the layer thickness, but your layer thickness is constant. Now, there is a problem. You can see. So, find out the ratio of the time required to scan the decubing lines and outer periphery of the given object. So just remember, whenever this type of problem comes, this formula you have to remember. Okay. This formula is basically you have to count how many lines are there which is getting scanned. First is this 4A is getting scanned. So 4A plus then this how many lines inside is present. So one is A. So you just have to count the lines. This is how you get the formula. And for inside it's D, so 4D, and D is equal to 1, 2, 3, 4A. And A is equal to 1, 2, 3, 4, 5, 6, 7, 8. So 8A. Now you know the ratio. So ratio comes 6.5. You just remember this question because this type of question came in previous year. So it's a very easy question. So you can just practice by your own using different geometry you can take and then calculate. This is one example of the part which was made, which is a crankshaft using this loam technology. So it can really print very complex geometry, but it's a very simple process. Next comes the Kira's paper lamination technology. There you are using the paper, then bond and form, knife, adhesive, and entire region. So it's again same. The principle is same, but here you are just cutting the paper with a knife. So there's a paper roll, there's a heater, there is a cutter, plotter means a, a frame. This is a frame onto which another frame is mounted, onto which this knife is mounted. This is the knife. This knife is mounted on this frame so that it can be connected to the CNC and you can control the motion of the knife in a very fast and accurate way. That's why this huge portion is there. And this is the heater. Heater means you are just pressing so that two sheets can be joined together. Here also you are using the paper, and after one layer is done, you can use the knife to cut it. There are some video in the lecture you can see. The overall process is same, decubing also same. Only thing is instead of laser, you are using knife. So again, you are saving more money. So Kira's paper lamination is it should be comparatively less costly, but you cannot directly relate because there you are using laser, which needs some cooler and some other arrangements also. But here for the knife, you are using a complete CNC machine and a heater also. So it's comparable, but still Kira's paper lamination will be less costly than cubic technology low.
Ma'am, does decubing means what you shown with the blue lines, that thing, removing those
Yeah,
things?
yeah, yeah. You just
Uh,
take the some kind of spatula or some kind of knife or some tool to detach the cubes which got cut. That is the decubing. Now comes the, sorry, did you say anything? Okay. So Lady mentions plastic sheet lamination process. So it's a little bit different, but here we are using plastic, same bond and form, knife adhesive, but selective region. So the adhesion or the bonding is taking place in the selected region. How there was a video which is not here. So there is a masking process. Masking means basically you are cutting the selected area. So here the adhesion together with selectively applied release agent, the masking agent. So the mask is used so that where the mask is not present, there you can release the selective glue type material to bond the two sheets. When the bonding is done, you can take a knife which is mounted on the CNC machine again and cut the rest of the portion. So you can see how small this machine is. And here you can just put the paper, put the mask on. Where the mask is not present, you put the glue and then you remove it. You put another paper. These two papers are joined now. Now you take the knife with the help of this CNC machine and then cut the region where you do not want to print the part. Simple process. Ironing in is nothing but you can just put a roller onto it so that the glue can be spread uniformly over the paper and the paper can be glued together or the plastic can be glued together uniformly with each other. Like the layers can be uniformly thick and joined properly from all over the bill plate.
Is it a roller or
So it can be a roller, it can be an ironing bar, like which is moving from
it is
one side to another side.
a hot plate? I think
Hot
instead of
plate
roller,
kind of which is moving from one part to another part, or it can be stationary as well.
see, the main difference between uh, Keira's paper lamination and LOM is there we are using roller, but here it is a hot plate.
Yeah.
Told like that.
Yeah, yeah. So and also in Kira's technology, where is it? Here also you are using a heater kind of which you are pressing, not kind of rolling. Then comes our next technology where you can use ceramic. So let me tell you, these are not very common technologies to be used for sheet lamination because here you can see you are using ceramics, which are already costly. Then you are using laser also, which is also costly to cut. And then you are using sintering. Sintering also will take some other machine, another part in the machine, and then entire region you're joining. So cutting is also one problem. So in this CAM-LEM-CL process, so the laser is there to cut. After it is sliced, you can do the stacking. Then lamination. Lamination is hot isostatic pressing means you can put it in a chamber where the heat and the pressure both are coming in the same time from all over the direction so that all the sheets can be joined together. Then this is called the sintering process. And after the sintering is done, you can remove the support structures. So in sheet lamination, as we are talking about, all the sheets are getting joined and you are doing the decubing operation at the end, you can notice one thing. this process doesn't require any support structure. The conventional support structure is not required because you are already having the whole paper with you in the whole time for the printing. So that's why extra support structure is not needed. You can just decube all the rest of the papers and your support structure work is also done. And a lot of heat is not used in this process. So one of the working or the one of the use of support structure is to dissipate the heat from the printing region. So that point is not valid here because you're not actually putting a lot of heat in this process so that you have to dissipate the extra heat. So from that point of view also support structure is not needed. And you don't have any overhang portion as such because of the other paper region. So that's why also support structure is not required. However, I'm saying like support is removed, but the conventional support structures are not needed in these processes.
But where the
Then
sintering operation is carried,
sintering
where the
is nothing but you can
where
just
it will be
press.
carried out in the machine itself or
No, no,
any
in the
furnace.
machine itself.
So that much temperature it can withstand the machine.
So it
Sintering,
depends that if you are
we are
having the
adding
machine
actually
in
we are
the
using metals, no, metals and ceramics.
ceramics. So
So
ceramics can be joined in sintering easily because their melting points are very high. Also, just after melting, their burning point is there. Ceramics don't melt, they generally burn. So that's why for ceramics, sintering is the only good option. So in sintering, what happens is there will be pressure and temperature at the same time through which the ceramic sheets or the ceramic powder join together, and there will be no porosity in between. That is the sintering operation.
Yeah, but what I am asking is whether
Okay.
the
Yeah.
sintering process will be carried out in that machine itself or it will be carried out separately in a different furnace. That is my doubt.
So so it can be two types. Both the things can be possible. If this machine that you're purchasing is having the sintering unit itself inside it, then your machine cost will increase. Both the case can take place. You can do the stacking and then you can put it in the furnace for the sintering. And there can be a machine where the sintering can be taken place in the same machine inside it. The cost will increase. Whether this company sells both type of machines or not, I don't know. But both the cases are possible.
no, that means after lamination, we need to take that object from the machine.
Yeah. So sintering is not the only process that is used in this technology, or this is not the only process where you are using sintering. In other type of AM also, there is another AM where you can mix the metal powders with the resin and then you can print it in a wet photopolymerization process, and then actually you can sinter the part in a furnace to get the final object of the metal powders. That can also be done. So here in this process also, it can also be done that after lamination, you just put the object in the furnace for the sintering.
But that is the criteria because here we are using metals and ceramics. So this is actually will not happen in other processes.
Yeah,
So,
yeah.
yeah, that is why high temperatures are involved. So whether that can be that process called sintering
So,
can be is
but what I think is, if
so
this
that is
company, yeah,
yeah.
so if this company is selling this machine, which demands for the sintering operation, then they are obviously selling the other part of the machine, which is the furnace.
The furnace, then high temperature, no, that whether it
Yeah.
can resist those all that environment or not.
Yeah. So this, if not inside the machine, then there will be another separate part of the machine where the sintering is taking place. Because generally, when a company is demanding that our part can be used only after sintering, then they will not rely on the other company's sintering machine. So it may happen that this company sells two-part machine. In one part, the lamination takes place, and in the other part, the sintering takes place. This is my belief that it should be the case.
There it is mentioned as hot isostatic pressing.
Hot isostatic pressing is a very high costly thing.
Yeah, that is what is mentioned in the slide, no?
Yeah. Hot isostatic pressing is one type of sintering, and if they are demanding for it, then they are selling the other part of the machine where you can perform this sintering operation. But obviously, it's ceramic and the layer thickness is very less. The part size will be very less. So that's why the machine will not be very big machine, but it's a two-part machine.
Okay.
Now comes the advantages. So internal channels and everything are possible because you are cutting the sheets and then you are laminating it. Disadvantage, shrinkage. Shrinkage is one thing because again you are doing the sintering. So after sintering, the shrinkage will be there. The porosity will be very less. So that is also the advantage of sintering process. Then comes our EOF. Where we are using paper, foam and bond. We are using knife to cut, adhesive, and the entire region is joined. So first, this is the cutting knife, which is used to cut the excess part. For the bonding, so first we are cutting, and in the cut portion, you are putting the next paper sheet, and adhesive is used for the adhesion of two sheets, and the entire sheet is joined. Later on, you can remove the excess part from the part. So this is more likely to be the normal process of the sheet lamination, what I have shown you in the first slide itself, where you cut the excess portion of the paper using the knife, and then you join the two consecutive papers so that you can get the two layers joined properly using the adhesive. Here comes the advantage and disadvantage. It's more likely, yes.
In last method, does CL have any full form?
CL?
Now, in the previous
Oh,
method.
this? I don't think so. CL has a full form. I also don't have the full form right now. But CL should have some. No, CL is like the CAM and LEMs is CL.
Okay.
This is the name, computer aided manufacturing. So CL's full form is computer aided manufacturing of laminate and engineering materials. So here is our last slide. Next comes to the very different sheet lamination process, which is the ultrasonic consolidation. Ultrasonic consolidation means we are putting some ultrasonic waves. So obviously the material has to be the metal. Here we do the bond and then form. That means we are joining and then cutting. For cutting, knife will not be useful, obviously, because it's a metal. Laser, it's difficult and it's costly. If you are talking about lasers to cut metal, it's very costly because you have to go for high power lasers. So milling is one less costly option to remove the material. Also, milling is accurate also, so it's good to use to save the cost and to use the cut the material. Diffusion bonding takes place and selected area. So ultrasonic consolidation. So in summary, we have metal sheets which are coming on one onto another, then bond and form. So the bond is also taking place in the selective region, because ultrasonic consolidation means you are using a big ultrasonic cylindrical tool through which you are putting the ultrasonic wave into it, pressure onto it. So it takes a lot of time and cost as well. So you will not join the entire region. So you can just remember the thing like that. That if you are using ultrasonic consolidation, obviously it's a costly process. I'll not join the entire region. I will join the selective region. After joining of the selective region for each layer or each 5 layers, I can remove the material from the excess part. And to remove the material, laser will be quite costly because it's metal. We need higher power laser. So I can go for milling operation. And as it's ultrasonic waves or ultrasonic pressure, so that's why the bonding will be diffusion bonding. It will not be sintering. Obviously, you are not putting any like the conventional heat and pressure. Adhesive is not possible for metal. Welding we are not doing. Soldering we are not doing. So it's the diffusion bonding. You can remember like that.
How diffusion takes place?
Sorry.
How diffusion takes place? For
Diffusion means when you have two materials, you have the atoms in the material. So ultrasonic consolidation material joining is a little bit tricky. So it's not melting properly, but diffusion means these atoms are the atoms of the last or the electrons in the conduction bond. They are getting diffused to each other so that these two metal sheets can be joined properly. It's not melting. It's not welding. It's not glue. It's the diffusion bonding. The atoms are getting diffused from the two joining surfaces of the two metal sheets.
Yeah, some amount of heat is required, no, to for
Yeah. And also, if we are ultrasonic consolidation means you are putting repetitive ultrasonic waves, pressure between these two metal sheets. So it's like lot of pressure is going actually, because of which the heat is getting generated. Clear?
So any video is there to understand?
Videos are not with me, but okay, let me finish this slide, then I can show you something from the YouTube. So because of the pressure, the temperature will be there, obviously, and because of the temperature, the atoms get vibrated or energized, and because of the high energy in these atoms of the surfaces of these two metals, the atoms get diffused between each other and the metal gets joined. Then comes the process, how it takes place. So it's a very costly machine because you are taking help of a tooling which is called the ultrasonic uh, wave. So you have to have this sonotrode. This sonotrode actually is the part through which you are putting the ultrasonic oscillation inside the metal. This sonotrode is mounted through this spindle arrangement through the transducer. This drum is basically, this can rotate. Also, it can come from the top of the machine. So in this picture, it looks like it's rotating, but it can also look like this. This is your part, for example, like inside your part, you have the layers. and the sonotrode is coming like this. This is the sonotrode, which is having the circular cross section at the end, and which is actually putting the pressure at an ultrasonic speed. The speed to in which the sonotrode is coming, touching the metal, and then moving up, touching the metal, and then moving up. This speed is in ultrasonic region. So it's very, very fast, you can just say. So fast that you cannot see in your bare eyes. So that is the ultrasonic wave that you are putting in your metal. So in that speed, you are putting the pressure onto your metal so that a lot of heat is getting generated. This is the mechanical arrangement, how this oscillation is generated and how this high force and pulses are coming. This is the way the roller will move and rotate onto the part so that these two portions can be joined. When it's moving here, it's putting the pressure, it's in ultrasonic oscillation. When it's rotating here, it is having, but when it's rotating from here, it's not having. So that its selective region, the selected region is getting joined together, not the whole region. And if the excess part is there, the milling operation is there to remove the excess part. This is the CNC milling operation. Milling, we all know, there will be a milling tool which will rotate and move in XY direction to remove the material layer by layer. This is the video. Actually, there is a video. If you see the lecture, there is a video of this process. So you can go through, there are only 2 lectures in this week, so it's easy to cover both the lectures together. So I would recommend you to go through the lecture videos. There you can see the video of all type of processes that were discussed, almost. So how the bonding takes place when we are talking about these 2 surfaces. So the 2 surface will have some surface roughness. Even if you touch the metal and if you feel that it's very smooth, it is not. In the micron level or in the submicron level, this surface looks like this. The surface looks like this. There will be some valleys and there will be some mountains, like peak and valleys will be there. When you are putting this ultrasonic oscillation through the sonotrodes, you are actually putting the pressure onto these 2 metal surfaces. Now, these metal surfaces are having some peaks and valleys. When you are putting the pressure, and if there is a peak here and there is a peak here, these 2 peaks will first receive this vibration and try to get joined together. Okay. Now, if there is valley will come later, but the peaks will be joined together. And when the peaks will start joining together, this is how the vibration is getting transferred from one metal surface to another metal surface. And by peak joining, then the whole surface will be eventually joined. And this joining is also taking place by diffusion bonding. Like the peaks are getting diffusion bonded together. Now, this is the whole process that is discussed. You can go through the process. This week lecture was really very short. So I hope you will not feel a lot of difficulty. See this picture. When you are putting the force, the atoms are getting vibrated. The atoms are getting energized. Now there is the peak and valley situation here. The peaks will receive the force first and try to get joined together because they are in a high energy zone kind of, because they are getting the energy. So because of which the atom will be diffused, and eventually by peak joining, later on the valleys will also get joined and the whole surface will get joined. This is what happens from here to here.
What is
And
actually the
also the, yeah,
sonotrode? What is a sonotrode?
sonotrode means the nothing but a very heavy, very rigid, metallic, cylindrical tool which is receiving this vibration, this ultrasonic vibration, and which is transferring this ultrasonic vibration in the metal, which is the metal contact. Sonotrode is this wheel, okay, and this wheel is very heavy because it's very rigid. It's it's made of some very high strength steel or tungsten or something like that, okay, and it's vibrating at this ultrasonic range, so it can withstand that ultrasonic vibration and it can transfer the vibration to the metal surface. That is the sonotrode. That is the tool basically.
Yeah, it is a shape is similar to roller, but in addition to
Yeah, it's
roller
just the roller.
pressure, sonotrode
Yeah,
in addition to pressure, it is going to provide some vibration kind of thing. We can
yeah,
take like that.
yeah. Sonotrode means it's a cylindrical tool which is receiving the not receiving. So you just imagine a cylindrical uh,
Roller,
roller you are having in your hand, a metal roller, and you are putting the metal roller on a metal surface at a very high speed, at a very high pulse rate. Okay, you are just knocking the surface with that cylindrical roller at a very high pulse rate. Pulse rate means you're hitting and then you are putting it back, hitting and then putting it back. So this
some
is
sort
how
of vibration.
sort of
In addition to
pulsing.
pressure, in addition to pressure, it transmits vibrations also into the.
Yeah. So vibrates means the pulse rate which you are giving is now manual. So it can be like 5 pushes, 5 punches per second. Okay. But now you are putting this pulse rates in an ultrasonic range, 20 kilohertz. See. So that high speed pulse rate is like you cannot give it using a manual hand. So you have to connect it with the machine. So the machine is called the transducer. So the transducer is now giving the vibration to the sonotrode, and sonotrode is just hitting the surface. But the hitting the surface is very like the pressure is not that much. It's not very high, but as it's in ultrasonic range, you cannot see it, but it's just hitting the surface at a very high speed. Hammering, basically. Understood? So sonotrode is that roller which can withstand the sonotrode characteristics is also important. So sonotrode is a very rigid, it should be very rigid. It should withstand that vibration. It should not happen that because of the vibration and the hammering operation, the sonotrode got some fracture inside it, or it generated some crack and propagated inside it. It should not have any crack inside it even after that high pulse rate for a very long time. It should be very rigid. It should be very heavy. It should be corrosion proof, wear proof, high strength material. That is called the sonotrode. So some knurling patterns you can find over the sonotrode, so that it's like instead of the whole area, if you are putting some knurling of uh, thing, then you can just put some concentration of the load will be more. If you are putting a surface and if you are putting the load through some points, then the concentration of the pressure will be very high. So that is what we are achieving with this knurling patterns. You understand this point?
Means
Yes.
contact area will be points instead of surface, right?
Yeah. The stiffness is also one point. So travel speed, amplitude of vibration, normal load, temperature of the base plate. These are all the process parameters for this operation, for this additive manufacturing process. And these are the process parameter which are deciding the printing speed, the printing quality, the layer height or layer thickness, the bill plate volume also. So texture of the sonotrode, electrical power supply, the stiffness of the machine, these are also some process parameter. But you cannot change this process parameter in between. These are the parameters which are affecting the process, but these are the parameters which you can change throughout the process to get a better manufactured part. Then surface topology, material property, presence of surface contaminants, oxides, stiffness, hardness. These are the property of the material that you should take account before starting the process. These are the parameters which we have to first study, and then you have to find out or optimize these parameters based on the material properties. So these are the material properties that we see here. We don't see the melting point. We don't see the heat conductivity because these are the process parameter you see for laser melting processes. But we see these parameter of the material before starting the process. This is the photo and videos actually which shows the process. This is a nice video. So if you see this video in the lecture, you'll see when the roller is pressing these two metal strips by the ultrasonic vibration, how the stress which you are putting is actually getting, or how it is going inside the metal, how it is spreading inside the metal. This is what is shown in this simulation video. Now, the main advantage of the process is that the ultrasonic vibration can benefit us in terms of the dissimilar metal joining. When we join the dissimilar metals, it's a bit problematic because either we are using metal wire or metal powder in any other metal AM processes, but here we are using metal sheets, which is less costly. And then in other metal AM processes, we are using some heat source to join the metal powder or wires. For heat source, we are either sintering or we are melting. In case of sintering, only powder bed fusion is there. So it's very, very difficult to print this multi-material thing. So just let's not take that example. For wire or powder in DED, it's difficult to control the process parameter because if you are taking two metals, the melting point, the heat conductivity, the diffusion, the solidification, these all properties will be different for different metals. So that's why it's very difficult to control the process. But here the metal is not getting melted. It's just diffusion bonding. So you can take any metal and then join together at a very low cost. It's interesting that you are using metal, but you are printing metals, different dissimilar metals at a very low cost. From that point of view, ultrasonic consolidation is a very, very cheap process. But in general, rather than other sheet lamination processes, it's the costliest one. So from the literature review, these are the metals, dissimilar metals, which was found joined using this sheet lamination process. The aluminium was joined with all other type of metals like aluminium, copper, iron, magnesium, molybdenum, nickel, every type of metals. Then beryllium was joined with aluminium, copper, and iron. Then copper alloys were joined with gold. iron, magnesium, molybdenum, tin, 8, everything. Okay. So nickel, platinum, silicon. So these are the black dots you can see, which were found as a proof of this process that ultrasonic consolidation can actually join all the type of dissimilar metals together. Now, if you talk about the process parameter, how to optimize the process parameter, then you have to take account the equations that we already know about the ultrasonic vibration. I'm not going to dictate all the equations. These are pretty simple. You can just see, but there is no such question came from this part of the lecture. This is just for your knowledge that how you can derive the motion of the sonotrude from the velocity and acceleration of the sonotrude, how it is rotating and moving at the same time, so that you can find out the contact length, how much the sonotrude should move in between the metal strip at how much velocity and acceleration, how much should be the vibration uh, parameters. Then comes the advantage, disadvantage, and that's it. So now I think we can start the question answers. Is it okay? Do you have any doubt?
So this
Yeah.
ultrasonic kind of lamination is the last one.
Yeah. Yeah.
I
These
think
are
a lot
the
of
all type of sheet lamination.
so a lot of concepts are involved in this ultrasonic
Yeah.
kind of lamination.
Yeah.
Okay. So if you go through the lecture, then I think we can understand.
Yeah. You can go through the lecture videos and it's pretty easy. It's not very difficult. This
Yeah.
part of the aim is very easy, and sheet lamination process is actually a very easy process. So you can easily go through and understand. So these are the previous year questions. Let's try to answer. But this week's lecture was pretty memorizing thing. Like you have to memorize which company is producing which type of machine. Anyway, the cubic technologies loam, the CL, the Kias, these are pretty easy and interchangeable, like easy to remember because these have only one difference between each other. So let's try to answer this question. So these questions are open for you guys, so
Other
you can
thing,
answer which type
for
of
this
bonding
answer,
we can. Sorry, can you repeat?
the answer is addition.
Yeah,
The type
so
of bonding mechanism.
it's addition. For the statement below, select the correct option. Form and then bond approach is suitable for materials like ceramic. Bond and form are suitable for materials like paper. Both are true because you can understand from general knowledge that paper is easy to cut, whether it's bonded or not. So even after bonding also we can cut the paper. But for ceramics, these are very brittle. So if you are joining the ceramics and then cutting, it can be little bit difficult. So it's better to cut the ceramic first and then join properly so that my part can be intact and there will be no harm to the part, because after joining the ceramic, if you are going to cut the ceramic, there can be some cracks inside the actual part. So it's better to form and then bond. Which type of bonding mechanism is used in Kira's paper lamination?
Yes, a binding binder is used. A
So it's
toner kind of
adhesion only.
adhesion.
Adhesion. With respect to cubic technologies loan, select the correct options.
It's just paper sheet. It's
Yes.
correct. And then form,
Decubing is used. So it uses paper sheet as raw material form, and then bond is not true. Layer thickness can be varied, not true. So it uses paper sheet as raw material is also true. So these two options are true. So you can, if it's multiple answer type, then it's fine. If it's not, then you can tick any one of these two.
1 and 3.
One and three. Which one of the following process will result in more strong part? So it's the Kira's technology. Because in Kira's technology, if you remember, we are putting the pressure heater. So it will be more rigid because the heater is also the perpendicular force you are putting on the part. With respect to Kira's technology, select the correct option. Again, it's same. Both the options are correct. It uses paper sheet as raw material and knife is used for cutting the layers. Both are true. Peel away method to remove the support is used in which of the following process?
Solid. Third one.
Solid dimensions, plastic sheet, lamination. How the support material is removed in cubic technology slow. This is very easy.
Decubing.
Decubing. Which one of the following approach is used in cubic technology slow?
Long. Bond and then form.
Yeah, we are doing decubing. So obviously we are not forming it. We are bonding the whole thing and then at the end we are cutting the parts away. So bond and form. Which of the following approach is used in Kira's paper lamination?
Whereas they're also saying means bond and then form.
Yes, it's same. Kira's and cubic technologies loam is almost same.
Almost same.
Yeah, it's just like there in Kira's we are using the knife. In cubic we are using the laser to cut. Bond and then form. What type of raw material is used in cubic technology system? Again, very easy question.
Paper
Paper
sheet.
sheet.
Paper sheet. Which type of raw material is used in Kira's lamination?
They're also, is it paper sheet?
Yes, in Kira also paper sheet, loam also paper sheet. See, the name itself suggests Kira's paper lamination technology, PLT.
Oh, yeah, it is there in the name itself. Which
Yeah,
tool is using?
in
Knife.
Kira's
Kira.
paper technology for cutting the layers.
Knife.
It is a laser, no?
No, it's the knife. In loam, it's laser. You can remember like loam, LOM, so laser. And Kira's
Is a
KIRA, so knife. K.
yes,
Okay.
yes, mechanical.
Okay. So how the support material is removed in solid dimensions PSL.
Peel away method.
In
Peel
peel
away
away
method.
method.
So it's the peel away. It's a little bit different process than Kira and loam. Which of the following approach is used in solid dimensions paper lamination?
It is yeah. The first we form and then bond. That is by peel away.
It's bond and then form. That's
Hmm?
why peel away.
It is formed then bond, no?
No, it's bond first. It is bond, and then after that we are peeling away.
Like LOM also it is like that, no?
Yeah, normal also it's like that. These three processes are having same bond and form. Only in solid dimensions we are using plastic, I think, as I can remember.
Bonding is
So
selective in solid
yeah,
dimensions.
bonding is selective because we were using this question is the next one. The masking we were using in solid dimensions. So bonding was selective, but we were using bond and form only.
That's correct.
Option 1.
Masking.
Application of glue, ironing, then cutting and trimming. Good. Then what type of raw material is used in solid dimensions? As I
Plastic
just
sheet.
mentioned. Here we use the plastic sheet. So this is the
Plastic sheet.
only difference from the Kira's cubic technologies and solid dimensions.
It is there in the name itself. Plastic sheet.
Yeah, plastic
Solid
sheet lamination. So plastic sheet. Which sheet-based AIM process can be used for processing of ceramic materials?
That is CAM. Last one.
Yeah,
CAM
it's the last one, CAM LEM. Which one of the following approach? There is someone.
Here first we form and then bond.
Yes, we do.
Form and bond. Form and then bond.
Yes, we do form and then bond because it's ceramic. So ceramics cannot be. It's difficult to cut the ceramic after bonding. So it's better to form and then bond. In ultrasonic consolidation based sheet AM, the transducer is used to convert.
So there is
See, try to remember what we are putting in
Electrical
the
to
metal.
mechanical.
First, the sonotrode is there. The sonotrode is connected to the transducer. And we
first
are
one.
putting what type of energy to the metal using sonotrode?
First,
It's the
Mechanical.
mechanical energy.
So mechanical into electric.
No, we are putting mechanical energy in the metal using the sonotrode. So the ultimate output is mechanical energy. Now the
So it is
sonotrode is connected to the transducer. So the answer should be the electrical energy is coming to the transducer. The transducer is converting it into mechanical energy and giving it to the sonotrode. Now the sonotrode is transferring that mechanical energy in my sample. Okay.
Okay.
Yeah, think in a reverse way. Which of the following approach is used in this ECOF?
Annex Corporation.
So it's the bond and then form.
On
It's the normal SL sheet lamination process that we were discussing. Which type of sheet-based raw material is used in UC? It's very easy.
so see, what about the earlier one? Annex Corporation. I think it is form then bond.
It's
It is
the bond and form. It's written
no
here.
knife we are using.
Okay, it's a normal one. So it should be form and bond. Maybe the answer was wrong. The answer I took from that site only. So maybe the answer was wrong, but you are correct because we were doing the normal thing. We were first cutting the sheet and then we were bonding. So it should be form and then bond. Good. Now, what type of material is used in ultrasonic consolidation?
Material metal.
Yeah. The bonding method used in ultrasonic consolidation is
Diffusion.
Diffusion.
diffusion bonding. Yes. To amplify the amplitude of vibration in UC, which is used.
Amplify the amplitude of vibration.
External force.
I mean, I can guess like booster.
Yes, I
Yes.
should. Booster.
So
Yes,
by
it
guessing also some of the options can be correct because it's boosting. So booster.
to amplify. Yeah. To
Yeah.
amplify the
And 18 is which of the following approach is used in ultrasonic consolidation? It's again first bond and then form. First, we are ultrasonically putting the energy and then we are doing the milling operation to cut the excess part.
milling operation.
So the last question, okay. How the unwanted material is removed from UC? I just
Milling.
said.
Milling.
So
Yeah,
it's the milling operation. So the question is same as what I have shown in the PPT.
yeah.
Okay.
The ratio.
The same question here. The number of cube is a little bit more, so that's why the formula is a little bit different. Otherwise, it's absolutely same. So you can just note down the formula. You can note down the question as well for your practice.
Ma'am, can you explain the logic behind this problem? How to solve?
Okay, so the
No.
logic is that how many lines are there? Okay, it says how many decubing lines is taking the excuse me, and sorry, how many lines that is taking for the black one is TC. Now lines means you just see this black line, which is equal to D. And inside D, we have 1, 2, 3, 4, 5, 6, 6A. So D is equal to 6A. Okay. And A is this bigger one where the blue lines are there. Basically, you have to count the blue lines. Okay. So it's up to you how you count the blue lines. You can do like first the bigger blue lines. So I can see 4 A's are there. A is 4, right? This is A. So so this is A. 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 Right? We have 4 A's. This is also A. This is also A. This is also A. This is also A. But we have some overlap. So let's just take that this is the 4A. Now let's go inside. If I now see this line and this line, these lines. So 1, 2, 3, 4, 5, 6, 7. 7 into 1, 2, 3, 4, 5, 6, 7. 7. 14. In one side of the cube, I can see 14 lines are there. These lines I am counting. You understand? These lines I am counting. In this 14 lines, till here, sorry, till here. From here to here, we have 14 lines. In 14 lines, we have 2A, 1 and then 2, 1 and then 2, 1 and then 2, 1 and 2. So 14 into 2A. Okay. This thing is for one side. So obviously for another side into 2. And 4 A's are there. Inside also 4 A's will be there. So that's why into 2 to 4A. So basically we are counting just the blue lines. It doesn't matter how you count. You can count like that also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that also you can count. You have to just count the number of blue lines. Now if you see the formula, this bigger A, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10A, small a, because 1 is small a. This one line is equal to small a. So caps A equal to 10 big small a and D is equal to small 6 small a. So I have just replaced the A's and now I get the answer.
Yeah, it is actually, we can say like this. That is the sum of the lengths of blue lines divided by the length of black line.
Yeah.
Okay.
This is
But that
the
is,
actual motif. You have
Yeah.
to count some way you have to count.
but for capital A, how it came, ma'am? For capital A. In the if formula of TG.
You can find another option also to count the A's. Like this is also A, this is also A, this is also A. This line is also A, this line is also A, this line is also A, caps A. You have to subtract the squares from it 4 times.
4 times.
Yeah.
Complete the length of the square.
Yeah.
Yeah.
So that is how also you
Yeah.
can count. So you have to just count it. Don't be bothered about this formula. And if you feel that at the time of exam it's very difficult to count the lines quickly, then you can just remember the formula that if you have these many squares in this side, then you have this formula. So whatever square you subtract and add, right, like that, you can change the formula. That is the shortcut, another shortcut for the exam moment. Okay. So these are the questions. I will put these questions in your that folder that I up where I upload the questions. Now I have this Mentimeter. So let's try these questions which you can answer. Here I haven't mentioned much about the Kira's technology, LOM and WC. It's the overall questions from sheet lamination. So you can scan this code using your phone and then we can start. Have you joined? So that's it. It's a little bit slow. I think you can see my screen. I could see another person in the meeting.
Yeah, barefoot contest. What does it mean? Enter that.
No, that is the participants. So there is your question. You can answer from the listing.
Morning before sheet is typically achieved by some. I'm getting some questions.
Yeah, so you have to just mark the answer that you feel is correct.
Yeah. Morning time.
So this PPT is like this marks will not be added in your exam. Don't worry. It's just a fun game. So the questions will come. The answers you have to mark and you have to mark as fast as possible. So when you mark the answer, you'll get some points. So here, if you see, there can be some points. The two players I can see. So when I'll enter, the question will come, then you'll get some time to answer. So answer as fast as possible. The fastest you answer, the more points you get. So it's just a kind of a fun game.
Okay.
So these are the two
Question.
contestants I'm having right now.
Okay. Respond quickly to get more points.
Which of the following is a major disadvantage of sheet lamination?
Sheet lamination, limited method. There is build speed. Very slow build speed.
So
Incorrect.
sheet lamination is poor surface finish. Waste generation is more because the whole paper sheet, a big sheet is coming, and now you are just printing a small portion of it. So it's huge waste, and surface finish is also not good because you are using paper. So the paper sheets can have some misalignment in joining and you'll get a very rough surface finish. Very slow build speed is not true because here actually the build speed is kind of fast than other processes.
Surface finish and waste.
Yes. So next question. Ready?
Ultrasonic additive manufacturing type of sheet lamination is mainly used for metals.
Yes. So both of you answered, but somebody will be fastest. Both of you were very fast. The barefoot contest.
Is by
This
default
is the
that
first.
name is
You can put any name.
now I cannot change.
So here is your question.
The excess material that surrounds the part is typically removed by cross hatching. Yeah, cross hatching. Cutting into small squares.
Yes, correct. Again, fastest. Good. We have our 5th questions ready.
Aggressive sheet almost is most. Oh,
So
sheet thickness.
it's true for all type of additive manufacturing that the layer thickness is one of the main criteria to get the accuracy. Good.
So this is the general point, no, for any
Yeah.
SLF,
Yeah.
RP, rapid prototyping. Sheet thickness is
3D
less,
bit.
means sheet more accuracy. That is
Yes.
irrespective of
Any type of additive manufacturing. Somebody has beat. Okay. Here comes our 6th question. Ready?
ultrasonic sheet lamination. The primary bonding mechanism is ultrasonic.
In ultrasonic, the primary bonding is mechanical interlocking and solid state welding due to ultrasonic vibration. Both are correct. Because mechanical interlocking means because of the peaks and valleys, which I discussed, the mechanical interlocking happens. And after that, it eventually gives rise to the diffusion bonding, so which is coming under the solid state welding also. Okay. Let's see our 7th question. Ready? Here is your 7th question.
So the following is an advantage of sheet lamination. Order beds.
So the advantage compared to powder bed fusion is faster beam speed and large part. High resolution can never be an option because powder bed fusion is the highest accuracy process for metal part welding. It's the highest resolution process. Okay, we have another contestant, Homer, with a donut. Okay, we have our 8th question.
Technology. Which run active.
So cubic technology slow means for paper sheets. We already have discussed, and metal composites are for ultrasonic consolidation only. Yeah, one contestant who is going up and up and up.
With barefoot.
Barefoot. Ninth question. We still have more questions to recover. Answer fast, quickly.
Can because of parts of dust is
So for conceptual models, it's good because,
Yeah.
as I mentioned, it is more useful for making patterns for later on, which you can use for making molds for casting. So it's weak. The parts are weak because anyway, you are making it out of paper sheets or plastic by adhesive joining. So it's not a very high quality joint. So mostly used for conceptual
conceptual
models.
conceptual model means only for a display purpose, getting some
Yeah, display
understanding.
purpose, rapid prototyping to show the part how it will look like after printing or making patterns.
Okay.
So here is our result.
So barefoot is going ahead.
Yes.
Yes.
Let's see. Next question. Who is barefoot?
Myself, why we are Murthy?
Oh, okay. Enter.
Respond quickly to get more points. Which company
Which
originally
company originally developed LOM before cubic technology?
that this is there? Which stats? I have a doubt.
So Stratasys is used for FDM, 3D system aim with the VAT photopolymerization. So only one option left.
Yeah, it is incorrect. Helicis.
Okay, somebody is going good. I think Homer has not attended the lectures and not even this doubt clearing session from beginning. Let's see
No negative
our
marks. No negative marks.
no negative marks.
Okay, then.
Main advantage of the early
Main
resilience.
advantage of LOM over
Strong
SLA
mechanism.
or SLS.
Strong mechanism. Yeah. This time I am right.
I think we can read the
Even that.
question carefully. Main advantage of LOM over early SLA and SLS. The low cost raw material and large build volume. Why it is
Yeah.
written early SLA and SLS? Because these days SLS can also produce very large parts. That's why it's written early SLS. But anyway, the low cost material is always a big advantage of sheet lamination for any demonstration or rapid prototyping. So let's see. Okay. Enter. This is our second last question.
Which of the following is
Major
made of
drawback.
slow build rate or limited time material? Yeah. This time also myself is correct.
It's a paper based. It's
Yes.
using laser.
High material waste.
Yes, and poor recyclability because anyway, in any sheet lamination process, you cannot recycle the part, the recycle the raw material. Because if you are using the VAT photopolymerization, you can recycle the liquid resin. If it's wire based, then there is no such wastage. If it's powder based, you can recycle all the powders. But this is the only process where you are having high wastage and there is no recycling process. Umar, you have to answer something right.
There are two answers. Okay.
This is the last question.
The main
The
reason
main reason sheet lamination struggles with lattice or highly complex geometry.
difficult to removing excess material. Wood launched.
This A is misprinting the question.
This material.
Just try to remember, we had already one answer in the last questions.
Yeah, I think I will one.
Difficulty in removing excess material, because decubing is the operation that we are doing. If it's lattice structure, then decubing is not even possible in lattice structures, because already it will be in millimeter or micro level intrinsic geometry inside. Okay, again fastest. Good. Barefoot is the winner. This is all about today's lecture. This is what I was having for today. If you have any other doubt, you can ask. Otherwise, I can stop the class here. Any more doubt? No?
Yeah. So
Okay.
I think this is about 6th week, no? From 7th week
this
you
is
have
the sixth.
another.
Yeah, every week we will have the doubt clearing session.
Yeah.
My session is on the Friday 6 to 8 p.m.
Okay.
Okay, then let's meet in our next session. If you have any doubt in between, you can mail me. Thank you for attending.
Thank you. Thank you for your session.